Okay, so this is going to be a longer video on creating these different cams and specifically focusing on how to use the parametric modeling tools that are built into Onshape to save you some time. And so one thing you're going to see in this activity with these different cams is you're making the same basic shape cam, but you're going to be creating multiple sizes that are all based on the same drawing. And so rather than redoing the same thing over and over and over again, the handout that you got is, it shows your cams, rather than using numbers, shown as different formulas based on what they call the nominal diameter. And so you could certainly start off by just making one of the cams and then going back and changing it over to a parametric model. But if you know right away that you're going to be using a parametric model, it might be easier just to start off that way. And so I'm going to go ahead and just go straight to my parametric model, and I am using, if I can drag it over here, I'm going to use the pair cam that we talked about first. This is a good example kind of in between some of the easier ones and some of the harder ones. So from the nominal diameter, I've got some different dimensions here that are all based on the nominal diameter and the axle diameter. We're actually going to be making our axle diameter square. This distance will have to be just a slight difference, but I'll talk about that here. Oops, Onshape was on that page. There we go. So first thing I'm going to do, I need to add in a variable. I can do a couple of things. I can add variables by going right here into my variable table. This is also where you're going to have access to see all of your variables. Or depending on how your screen is minimizing these, for me, variable is under here. And I can click that and I can define a variable right there. But it's just as easy to open up this side here and click add a variable. So I'm going to start off with a variable called nominal diameter. And I'm going to put this in what's called camel case. If any of you have taken computer programming classes, you've seen this. Or I guess since I capitalized the first letter, it's not technically camel case, but whatever. Nominal diameter, it is a length. And for now, I'm just going to set it at 2 inches. You have to give it a value to start with. But I believe you're going to be making cams that have nominal diameters like 1.5, 2, 2.5, and 3 inches. So we'll be changing that value. And you'll see over on the left-hand side, the nominal diameter shows up. Anytime you want to reference the nominal diameter, you use this pound symbol or the hashtag for those of you that are, not me old. The hashtag symbol there. And Onshape will bring up all the variables that you have defined and ask you which one you want to use. So from there, I'm going to go ahead and name some of these other ones. This one, I might call this one the large radius, just because it is the radius of this large circle. So in this one, I'll just type large radius. And I could just type in a number here and say, looking at my formula, it's the nominal diameter divided by 2. So if my nominal diameter is 2, I know this needs to be 1. But that wouldn't be very parametric. Parametric is when we try to tie the different variables together so that we can scale up and down really easily by just changing 1 or 2 dimensions. So I'm going to base this on the actual variable of nominal diameter. And so I'm typing the hashtag symbol. And you'll see a little symbol pops up here and says, hey, do you want to use this variable? And well, yes, I do want to use that variable. And then I'm just going to add a divided by 2 in it. And you'll see that it automatically calculates that value is 1. And the best part about all of this thing is if I change this to 3, it's going to update. So I've got a variable here that I don't ever need to change because anytime I change the nominal diameter, it automatically updates the large radius. And then I'll keep going here. I'll find the rest of these. Nominal diameter divided by 4. We'll call that one the small radius. So we'll do that hashtag. Now you can see both of my variables are showing up. So I want nominal diameter divided by 4. You can see it calculates that value. I need my axle diameter is going to be the axle diameter minus 0.025. Ours is going to change, and we've got our thickness. So our axle diameter, or yeah, we don't have axle. We're using a square, so we'll call it axle size. Our axle is 0.25. So that one doesn't need a formula because that is actually a number that is set. And then I'm going to make the hole size. In order for ours to actually work, what we found is that the best hole size to use is actually the axle size plus 0.05. No, 0.005. Is what we, whoops, axle size plus, why didn't that work? Axle size plus 0.005. Did not let me put that many zeros in there. What? Error regenerating. That's weird. Just gonna try something here. That one worked just fine. Okay. Plus 0.5. Well, this is odd. Oh, I know what I need to do. Axle size plus 0.005 inches. That's it. Okay. Yeah, you can tell. I've just started using this stuff too. We used a different program the last time I did this. So hole size is going to be our axle size plus 0.005 inches. And then the last one we've got to have is our thickness. And we're going to set that at 0.25. And so that covers all of the measurements that are in here. We're going to have small radius. Oops, I missed one. Large radius, axle or hole size, thickness. We need this, which I'm going to go ahead and just call like offset. And so that one is nominal diameter divided by 2 as well. And even though this is the exact same formula as the large radius, it's a good idea to have both of those because this is going to let us go back and make a change and say, okay, what if we want that offset different than the diameter? We could do that too. So I'm going to go ahead and shrink this down. And now I'm going to go ahead and actually make my sketch. So this pear-shaped sketch is basically made up of a circle, another circle, and then 2 tangents connected there. So that's what I'm going to go ahead and do. At this point, I'm just going to go ahead and make the general shape, not worrying too much about dimensions, and then I'll go back and add dimensions later on. So it looks something like that. I connect these with tangent lines. Each of these different ones is going to look slightly different. You're going to have to figure out how to make the sketch work. Yeah, there. What's going on with my computer today? Escape. Go away. Okay, so we got to put some tangent lines on these. Make sure that they stay tangent. They should be set there. And then one thing you're going to have to do probably on this one specifically is when you go to dimension these, you're going to see that it wants to dimension that whole circle. A way to make it dimension as a radius instead is just to go ahead and get rid of these extra lines so that it's only an arc that you're trying to dimension. So now when I go to dimension this, I can click I actually want. And so now I just go in and I hit that little hashtag symbol and I want the small radius for that one. Hit enter. For this one, I want the large radius. So I'll do hashtag and I can find the large radius, hit enter. My computer is getting real slow. That kind of messed some things up there a little bit, but we can get that fixed. There we go. Looks like I missed a tangent symbol there, didn't I? Okay, computer. We can do it. So I need a tangent symbol there. It looks like I also could use a vertical symbol there, couldn't I? There we go. Okay, then I got a couple more here. If you look at this picture, I've got to put that offset in. So that would be this distance from there to there. And again, I can put in offset. I've already defined my variables. I somehow missed another tangent. I don't know what's going on here. There we go. And then I'm not even sure what that thing's for. So we've got our pear shape generally constrained here. The last thing we need to do is put the axle hole in the middle of it. And so this, we're going to be using a center point rectangle. And it is a square. So when we go in and put, okay, come on. The computer is not running the webcast thing, screencast thing. So I'll go ahead and put in these sides here. Dang. It is not liking this. Okay, so I put that in there, and I can just go ahead and say, okay, that's going to be my hole size, and the same thing for that one. That's going to be my hole size. So it ends up being a 0.255 by 0.255 square. Then when I go finish that, I can do my sketch. Not my sketch, my extrude. Sorry about that. Do my extrude. And the same thing I can do with the sketch is in this depth, instead of typing a number, I can put in a variable. So I'm just using that little pound symbol or the hashtag, and I'm going to set that to the thickness. And that'll automatically make it into 0.25. Now that's a little bit extra work, right? That first one took the time of making all those variables and then using variables instead of a number. But here's where it is worth it. If I go into this variable table again, all I need to do to update this whole thing to a different nominal diameter is just change the nominal diameter. You see, when I change that, it updates the whole thing. And since I didn't make the square hole dependent on that or the thickness, it didn't change those. So it's not just scaling it up and scaling it down. It's scaling up only the variables that I wanted to based on the nominal diameter. Now, there are some more advanced features that go into this that you could learn how to use, because let's say I didn't always want that offset to be half of the diameter. Like, let's say I wanted to make two different versions of this cam and still have the ability to use the parametric tools. Well, I can use this configuration panel here, and this is a little bit more advanced. You're probably not going to be doing this, but for those of you that would like to learn a little bit more, continue on watching. I'm going to go ahead and make a list, and I'm going to add configuration features. And I want to have configuration features for pretty much all of these that are not the nominal diameter, because I don't want to be messing with the nominal diameter. I'm going to leave axle size alone again, because that is one that is just set. I'll include hole size. Oops, I never got small radius. So you see what I'm doing here? I'm clicking small radius, and then I'm clicking on the value. Clicking on hole size, clicking on the value. Thickness I'm going to leave, offset I'm going to change. So I'm going to be done with that now. Click on done, and you can see over here I've got one default configuration. I'm going to make that a little bit bigger. And so that's the default configuration, is that the radius is 2 divided by 2, the small radius divided by 4. The hole size is axle size plus 0.005. Offset is nominal diameter divided by 2. Now let's say I want to make a different style of pear cam. I'm going to go ahead and make this alternate cam. And you'll see it automatically pulls in the exact same values. But let's say for this one, I want my offset to be just a little bit smaller. So I'm going to go nominal diameter divided by 3. It doesn't look like it did anything because it didn't do anything. But over on the left-hand side, I now have a configuration option where I can change between the default and the alternate. And by changing to the alternate, I have access to that other version of the cam. Still with all the nominal diameters I can change. I could change this to a 3-inch alternate cam, and change it right back to a 3-inch default cam. So you can kind of see there's lots of different flexible options there that you can use to get different configurations of those different parameters. Now, the simplest way is just to ignore that configuration panel altogether and only worry about what you're seeing in this panel here. Just using the variables and changing the ones that are kind of like preset numbers. But there's how you make a, specifically the pair cam with parametric dimensions, parametric modeling, so that you can change values as you go. What you're going to be doing after this, I believe, is to go ahead and do that same exact thing for the other cams. So you've got access to the pair cam, and then you've also got to make your other cams as well. Those other cams. So we've made the pair cam. Now you can go ahead and try. I think I've assigned you a couple of cams to make on your own.